In this video, we're going to talk about scientific notation, which I've abbreviated SN, which I may use later, and decimal notation, which I've abbreviated DN and may use later. Specifically, our objective, we want to convert a number from its standard or decimal notation to its scientific notation and vice versa. And I should have written that, so give me just a second, and vice versa. We want to go back and forth from scientific notation to decimal notation. Well, first, let's define scientific notation. Scientific notation is a method of writing very large and very small numbers using powers of 10. And this is the way it looks. It's a number times 10 to a power. I'll put a box around that just to kind of highlight that. And in scientific notation, this number A in front is always a number that is between 1 and 10. It can be equal to 1. It must be less than 10. In other words, there is only one digit in front of the decimal point. Okay? And this number n is an integer. And you remember your integers, and I'll put that, your integers are your, I'll write them down here. Your integers are your whole numbers, 0, 1, 2, 3, and their opposites, -1, -2, -3, etc. So again, this is a number between 1 and 10. It can equal 1, but it must be less than 10. This is a number that is an integer, okay, -5, 20, etc., etc. This integer here, the exponent of 10, tells you whether or not it's a large number or a small number. If that exponent is greater than 0, it's a large number because you're multiplying by a very large number. 10 to the 15th power is a huge number. If this exponent is less than 0, you're multiplying by a very small power of 10, and it indicates you have a very small number. So let's take a look. A couple of examples, and then we'll do some conversions. These are actually some true statements here. The age of the universe. The universe is estimated to be approximately 1.375 times 10 to the 10th years. I think that's like 13 billion, maybe. We'll do that in a second. Again, notice here, this is my A. It's a number between 1 and 10. Notice there is a single digit in front of the decimal place. And then this exponent here is the N. Notice it's positive 10, which indicates that the age of the universe is very, very large, very old, okay? So there's an example of a very large number. The example of a small number, the length of the AIDS virus. Well, you can imagine viruses aren't very big, and so it can be written in scientific notation, 1.1 times 10 to the -4th millimeters. Hardly measurable with a ruler. Again, here's the A, a number between 1 and 10, but not equal to 10. You'll notice, again, a single digit in front of the decimal point. In this case, the N is a negative integer, which is telling us that this length is very, very small. Okay? The reason for scientific notation is because it's easy to lose the zeros when you get to such large and small numbers. And scientific notation makes it easier to not lose the zeros and therefore be accurate with your number. Okay, so let's convert. Let's go back and forth. Let's first convert from decimal notation to scientific notation. Okay, how do we do that? Well, we move the decimal to determine what our A is. Let me come down to here so you can see again. There's the A right there. So we're going to move the decimal to determine the value of our A. Remembering that A must be it's greater than or equal to 1, but it has to be less than 10. And then the second step is the number of places that we move the decimal will determine our n, our exponent. If the original number is greater than 10, then our n will be positive. If the original number is between 0 and 1, in other words, it's a small number, then our n will be negative. Okay, so let's take a look. 4,600,000. That's a pretty big number. I'll write it here, 4,600,000. And again, this is in decimal notation. There's always a decimal point. The decimal point in this case, we don't need to write, but it's right there. Okay, now we want to move that decimal point to create a number between 1 and 10. So I'll rewrite 4, 6 with 5 zeros. 1, 2, 3, 4, and there's the decimal. So I'll move it. Well, that's a big number. That's too big. 2, 3, 4, 5, 6. 4.6 is the number between 1 and 10. Notice I moved it 6 places. Okay, so my scientific notation is 4.6, and normally you kind of keep tabs on the numbers that are non-zero, and then we'll say times 10. It moved 6 places, and of course it was a large number, so it's a positive 6, and this is scientific notation. Okay, let's take a look now at a small number. This is, let's see, tenths, hundredths, thousands, 10,000s, 100,000s. This is 23 thousandths. That's pretty small. Okay, so let me rewrite that number here. And this again is in decimal notation. And this one we can see the decimal because we had to write it in order to have the correct place value. So we're going to move that. So let me rewrite it again. 1, 2, 3. I want to create a number between 1 and 10. 1, 2, 3. Okay, I'll put it here because this will be 2.3, and that's between 1 and 10. So I'll move it to here. It moved 1, 2, 3, 4 places. And so I now have it, the number between 1 and 10 is 2.3 times 10. It moved 4 places, but it's a very small number, so it moved 4 places to the right, which means I have a very small number, negative 4. I have the integer for the power of 10 is a negative 4. So 23 thousandths in decimal notation is 2.3 times 10 to the negative 4th in scientific notation. Let's go backwards. Let's go from scientific notation to decimal notation. All right. Let's get straightened out here. Okay. This is fairly straightforward. There's really no step 1 or step 2 here. We're looking at the n. If n is positive, okay, if n is greater than 0, we move the decimal n places to the right because we're going to create a larger number, filling in zeros as necessary to create a large decimal number. If the n is negative, remember that tells us we have a small number. So we're going to move our decimal n places to the left, again, filling in zeros as necessary to create a small decimal number. And I pulled those 2 examples from the first page about the age of the universe and the length of the AIDS virus. Let's take a look. I'll get my notes together here. So, age of the universe, 1.375 times 10 to the 10th years. Well, this obviously is in scientific notation. 1.375 times 10 to the 10th. Okay, again, this is in scientific notation. Okay, so now we note that the 10 is positive. If n is positive, we know that this is a large number, and that should make sense. The universe is pretty old, so that should be a large number of years. So we want to make this number larger. We do that by moving the decimal to the right. Obviously, if you move it here, it becomes 13, 137, 1,375, etc. So I'll write 1.375, And I'm going to be careful here. I need to move the decimal 10 places and fill in zeros as necessary. Well, there's 1, there's 2, there's 3. Okay, well, there's a 4th place, put a 0 in. I got to move it 10. There's a 5th place, put a 0 in. There's a 6th place, put a 0 in. 7, 8, 9, 10. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, I moved it 10 places. And now I can, I want to, in order to write it, the decimal is now over here. I should probably put some commas in to help us read it better. So 1, 2, 3, comma, let's put a comma there. 1, 2, 3, put a comma there. 1, 2, 3, put a comma there. So 13, comma, 750, comma, 0, 0, 0, comma, 0, 0, 0. Okay, and this is in decimal notation now. Again, we don't have to write the decimal, but it would go right there. Hundreds, thousands, millions, billions. So the universe is approximately 13 billion, 750 million years old. Okay, let's do the length of the AIDS virus. All right, so 1.1 times 10 to the -4th. And again, we know that the negative exponent of the 10 tells us it's a pretty small number. And of course, we know from just being human and knowing things that the AIDS virus is pretty darn small. People use microscopes to find these viruses. So we're going to we want to create a very small decimal number between 0 and 1. Okay, so I'm going to move it 4 places. Now I'm going to have to move it to create small. I'm going to have to move it to the left. Okay, it's negative. We're moving to the left. I'm going to write 1.1 on my paper to the right so I can move the decimal to the left and have some space. Okay, there's one movement to the front of that 1. I got to fill in zeros as necessary. So there's number 2, put in a 0. Number 3, put in a 0. Number 4, put in a 0. So now here's where the decimal will go. And notice I moved it 4 places. The negative's telling me that I need to move it 4 places to the left because it's a small number. And I can rewrite this. It's a decimal is in front. I have 3 zeros with a 1, 1. And this is now, what's that? I went from scientific notation to decimal notation. And reading this, let's see, 10, 100,000, 10,000. This is 11 100,000ths millimeters. Pretty small. So there you have it. Converting from scientific notation to decimal notation and back.